management tool, benchmark, quality function deployment, then failure mode effect analysis, and last technique is Taguchi method. This is the last in the fourth unit. Keep in mind, uh, when you just I want to brush up some important point which I taught in how the quality started. Actually, Japanese had nothing with them. Then they came into market. Within few years, they came into their market. They came into their own market. Then they went to US market. Then finally, people are buying the Japanese product instead of buying the US product in the US. They have beaten the US within few years. 1930, nothing they had with them. But in 1970s and 1980s, people are buying the Japanese product instead of US product. Then how it happened? Because one of the reasons is quality. They have given this word the term called quality. Then if you talk about how it was helped because of the quality gurus, already told you that. Then there is a two broad classification in terms of quality gurus, where the contribution came from the US people, US quality guru like Edward Deming, Joseph Juran, Lips Crosby. Then later what happened was, again you can have another classification is, you can have even a Japanese itself help the Japanese people. One of the quality gurus which given a lot of contribution was Taguchi, Genijik Taguchi. Actually his name was Genijik Taguchi, who came up with this robust method. They call it this as a robust method or Taguchi method. They came up with this concept actually. Taguchi method or Taguchi quality engineering. He is one of the quality. Another quality guru is Karu Ishikawa. Karu Ishikawa is another quality guru who talked about, who tried to give the lot of contribution to the Japanese in terms of quality. Then this Taguchi also given one of the not even he given in terms of quality, but you can talk about what you call Taguchi. Not even in terms of quality. I will talk about another contribution where he given in terms of statistician also. Not even this Taguchi method is applied for quality engineering or quality problem, but it was applied for statistical method also. They consider one of the important statistical method also as Taguchi. Taguchi method is considered one of the important statistical methods which improve the which help to improve the quality actually. When I talk about the Taguchi, when I talk about the Taguchi, then what you can tell about him is, already told you that this method is called as a robust design method. This method is called as a robust design method. Why design? Why it was designed? The reason is, always keep in mind, when you go for manufacturing, first the stage is design stage. First stage is a design stage where the product is designed. After a product is designed, the trial production is done, pilot production is done, pilot production is done. Once it is done, then they will go for, if it is successful, then they will go for actual production of actual production, which will they will manufacture the goods or they manufacture a product. They will try to manufacture, but then this is a stage it will go. Then, but all the method, when I talked about till now, most of the method it revolve around that. People are trying to use the all the techniques, whether it is a PDCA cycle or quality circle, failure mode effect analysis, or 7QC tools, or 7 management tools, or quality function, a lot of quality function. Always what they will try to do is, after either they will work for prevention, generally for the manufacturing, actual manufacturing, when the actual manufacturing start, they will try to identify their defect, they will work to resolve the problem. after detection, or they will work for the problem for prevention only for the manufacturing. But Taguchi emphasized that the design should be included when we try to do the manufacturing. Design should be included. He talked about that. He talked about that quality starts from the design. Quality starts from the design. He came up with a concept called quality start from the design. He told about that quality start from the design itself. It should not come when we do the actual manufacturing. Most of the quality start from that. Or even most of the people when they do the trial production after designing, whether they develop the prototype, even they will never talk about the quality at all. They will never talk about the quality at all. But here, Taguchi method will talk about the quality in design stages, and that's why this method sometimes called as a robust design method. Robust design method. Always keep in mind. Now it is important that quality gurus came up with a different what you call definition. It's very important that we have to define the quality. We have to define the quality, but genetic Taguchi has given the quality in different dimension. He has given the quality in different dimension, where he emphasized the loss impacted to the society, the loss imparted to the society. He came up with a concept that he defined the quality. Most of the people will define the quality in terms of customer satisfaction, in terms of customer improvement, or in qualitative design, in terms of fitness for use, or it is a quantitative metric like what you call conformance to specification. But he has given the definition of the quality in terms of loss to the society. So he defined the loss to the society from the product that's shipped. He given that concept that the loss imparted to the society actually. Then he given the term called the loss imparted to the society. Another important keep in mind, what is the loss to the society? Failure to meet the customer requirement. It given the customer buys a product. For example, if you buy the product, the mobile phone it's not working up to your level. Bought it for the mobile phone, then there is a problem in the screen, there is a problem in the battery, or whatever related the problem, that the failure he tells about that, it is a loss to the society. And even if you buy a mobile phone, then it is not working up to the performance level. It's not working up to the performance level. The ideal situation is that it should work for uh, in terms of years. When you buy the mobile phone, at least some ideal performance is given. For example, it is the ideal performance. Based on the ideal performance, the product should work. Again, given in terms of harmful, what do you call failure? Failure in terms of meeting the ideal performance, or meeting the failure from the meeting the customer requirement, or harmful side effects. He tried to give all in terms of losses. He came up with a all in terms of losses. When we talk about the Taguchi given in terms of design, emphasize that the quality start from the design. Then he tried to emphasize more on what he called uh, emphasize more on loss to the society. Another important thing where he given the contribution was when we talk about the what do you call it, Taguchi given important in terms of what he came up with the concept was given in terms of quality loss function. We talk about the quality loss function in terms of statistics. I told you that you keep in mind always what we do in statistics. We try to find the variation. We try to find the variations. What variation we have to do with it. That we can reduce the variation. Variation is very important. How, in simple term, if you understand the variation, what is the variation? Assume that today you want to manufacture a 100 mobile, then but you are manufactured nearly the 70 mobile or 80 mobile. 100 minus 70 or 100 minus 80, whatever it is, say 20 or 30, that is a variation. That is a variation actually. That is a important variation, where we try to how if we improve the if we want to improve the process improvement, then we have to reduce the variation. Then obviously the quality of product will be improved. Quality of product will be improved. That is why he talked about that. He talked about more. He talked about in terms of efficiency, how we can reduce the efficiency. Again, as a what he called, he is not even statistician, but people are appreciated his statistician. He has appreciated his concept. One is quality loss function, where he given one types of function as say. He talked about the quality loss function in terms of statistic. Another important he given in terms of design of experiment. Even ANOVA and people are trying to use the ANOVA regression. One of the design ANOVA used for the design of ANOVA, or most of the techniques are used for the design of experiment. Even he, Taguchi, contributed in terms of statistic to the design of experiment. Keep in mind, even he given the contribution in terms of design of experiment also. Another important thing is you have to understand the traditional method. If you talk about the traditional method, there will be upper control limit or lower control limit. The upper control limit, lower control limit is based on what you call sigma level. The target is mean. Sigma is nothing but standard deviation. The target level is mean. But what will happen over here is, if you look over here, there is a huge loss. This is the interpretation of this. When I talk about that, a quality loss function, traditional method, neglect the huge losses. Quality neglect the huge losses. This, if you look over here, they are neglecting the huge loss. Complete loss is neglected over here. When I talk about the quality, they are neglecting the huge losses. But that is why the interpretation of loss will come that this is upper control limit, this is a lower control limit. The huge loss is neglected over here. When I talk about the what is called quality, they are not even capturing the losses. That is why he came up with a specific loss function, where he tried to give the mathematical in terms of cost. Later we'll talk about what the this is a quality loss function, which is we'll talk about what is the quality loss function, which he tried to give, what cost function he calculated that. Talk about the loss function or statistical traditional statistical method are relied on what you call totally this method, where we are upper control limit and lower control limit, and this is a target actually, where we have a sample mean. Then this the most of the loss is not captured over here. Most of the losses not captured over here. That is why statistical method, where he try to capture the loss. When we try to talk about the Taguchi method, he try to capture the losses. He try to capture the losses over here. When I talk about here, then he try to capture the losses. So many losses he captured. Here he captured the losses, where we are trying to have a U-shaped curve, where we try to go U-shaped curve. This target is nothing but a mean actually. This is mean. When we try to talk about this is a mean, and this is based on the standard deviation sigma, which is based on the standard deviation. This is completely based on the standard deviation, and this is based on the mean. But if you look over here, there where he tried to talk about the mean captured, but he captured the loss, where he's trying to give the continuous interpretation in terms of loss. I told you that all this tool will talk about in terms of losses to the society. in terms of cost. Always keep in mind in terms of cost. Actually, he came up with a three loss function. Actually, later I will talk about the three loss function where he came up with the three loss function. We talk about the three loss function: larger the better, smaller the better, or target or minimum variation product. Later we'll discuss about that. And this is Taguchi who emphasize more on quality loss function. Now this is I told you what we talked about the three concept. We talk about the three concept. Talked about the three concept actually. Now let me talk about nominal the best. Nominal the best. Now let me talk about the process versus output. First, Takuchi has given the value of the characteristic, which is output. Which we talk about. Now look over here. This is a quality function where the target is again mean. Again, mean is a target. Then mean plus upper limit. Similarly, same concept of whatever is there, but just like a U-shape. This function is like U-shape. This function is like a U-shape function where we talk about the upper limit plus target, then target minus mean minus lower limit. Mean minus lower limit. This is this we talk about the loss function. Then there is a three methods are there. We called nominal the best. Now let me talk about the see the parameter over here. The parameters are there. L is there. Already told you that loss function. Talks about in loss function. It is more or less in terms of cost. Then we have S is a loss function. I told you that here. S is most in terms of cost. Is most in terms of cost. Cost is one of the important. Okay. Loss function in terms of cost. And output or sometime Y is this output or Y is sometime in terms of characteristic it is mentioned. Some density, weight, or whatever the characteristics mentioned for the quality of product. Whatever we measure in terms of measure in terms of quality of product. Whatever the parameters are we trying to use over here. This is the Y. That is what here given whatever the output or characteristics. Then we are trying to measure in terms of losses. We measure in terms of losses. And Y, what is the Y? Y is the performance. This is the Y is a performance. Y output for performance. And M is a target. What you want to achieve. Y, for example, if you want to measure the called your absenteeism, daily absenteeism, I want metric. I want to measure the metric in terms of daily absenteeism of the student, or mark of the student. That can be a Y. That can be Y. The target is given to you is assume that if it is a what you call late coming, it's a metric. Late coming is a metric. Late coming as a metric for you. Then what is the target you have to come? You have to come at 9:30. Then plus or minus 10 minutes. Then 9:20 to plus or minus 10 minutes. 9:20 to 9:40. That should be your target. What is the loss of cost function? The what you call the fee you pay. Sometime it is the late coming in given in terms of cost also. or assume that it is given in terms of reduction of marks. That's what it is given where. What is a loss to your. Now these are the what you called it is given. Already told you why L of I is cos incur as a quality deviates. Everything we are talking about deviate from the target. What is the target? Target is over here. Whatever we incur the cost, whatever we incur the cost because of quality deviates from the target actually. Then when we talk about the y talks about the performance characteristics. Then M talk about the target level. And K is a quality loss function deployed. Quality loss function which is measured in terms of loss to the customer EO. Then this specification is given whether it's upper limit or lower. This is the interpretation of the quality loss function. And there are different types of quality loss functions are there. There are different types of quality loss functions are there. When we talk about the quality loss function, then we have what we called nominal the best. If it is a nominal, then it is the best. For example, color density. It should not be too high, the dimension within the specification of limit. If it is a nominal, then it is the best. Then it is a nominal. Smaller the best. That if the target is 0, then obviously, then what you call it is better. For example, time. The time, for example, if you are coming late coming, if it is less, then it is better. If it is less, then it is a better. Sometimes we need to optimize that. Then we use a nominal the best. The color density should not be too high and should not be too low. Dimension should be within the specification. Then we talk about the smaller the best. Then obviously, just what you call the. If it is less, then it is the best. When we talk about uh, lesser is time, then pollution. Then like this, so many parameter we can talk about. Sometimes it is the larger the better. So it is the larger the better. It is the opposite to the smaller the better. Reciprocal of smaller the better. Then, for example, strength. For example, if you want to manufacture any bridge, if you have a strength, then it is better. If it is any car, then strength is important, capacity is important. If it is a larger, then it is the best. It's a larger, then it is the best. Another, these are the quality loss function which we talk about the quality. Another important concept is there in what you call in Taguchi. I told you about that important concept. Taguchi. I not put it in the slide over here. Then I talked about even in terms of statistical, even in terms of statistical, there is a another concept called offline quality. Offline quality control. Another important concept is there is a signal ratio also there, which I am not going to talk about. Very important is quality control is there. Quality control, offline quality control is there. Where he try to what you call realize the best opportunity to eliminate the variation of the final product of the quality. These are during design stage. Already told you that best opportunity to eliminate the variation. Generally, we have to work in prevention. This offline talked about in terms of design. I told you about that one concept that emphasize more on design. Emphasize more on design stage itself. Talk about more in terms of design stage itself. That's why we want to reduce or eliminate the variation of the final product during the design itself and its manufacturing process actually. If you design the product itself, you have to identify the what is the loss. Even along with the design, it doesn't mean that it does not even bother about the final quality of product in manufacturing process, and even he try to emphasize the what you call emphasize more on in manufacturing process. But it tells that it will start from the design itself. That's why what he try to develop in terms of what I told you, quality engineering also they will call it. Quality engineering also. That's why he try to explain the three different contexts actually. He try to explain the when I try to explain the offline quality he try to give in terms of three steps. Try to give the offline quality in terms of three steps. One, the important concept in Taguchi is one of the important concept is offline. I told you that offline quality control. I talked about offline quality control. About the offline quality control. The important thing is offline quality control, where he emphasized that we have to. That's why he talked about three stages. Three stages he talked about that. First stages talked about the system design. Design. Talk about the system design where he emphasized more on at conceptual level itself, where we have a conceptual level in design stage. In design stage, what we do there, in conceptual level itself, we will have the level where we design. Then you have to consider the quality. Consider the quality. He is a more emphasized. Then we talk about the parameter design. Then he talk about more on parameter design. Parameter design. Where he try to give the once we are develop the concept, then we have to find the various dimensional design parameters. Then various dimension. Then we are trying various dimensions and design parameters stage. Try to emphasize that the detailed design when we talk about when we design for parameters, then we have to consider the quality in various design parameters considered. One is conception set where we get the idea, there itself we have to consider that various consider the quality where we try to then it in many circumstances what will happen, it allows the parameter to choose to minimize the effect of the performance. That is why the robust parameter design is called. Sometimes this is called as a, or sometimes it is called as a robust. Sometimes this is called a robust parameter design also. We'll call it robust parameter design. Sometimes we call this as a robust parameter design also, where we try to consider the important thing is another important concept is where they calls a noise ratio. Calls a noise ratio, where we call as a noise variable also we call it. Generally we call as a noise variable. Call that as a noise variable. It's by an another important concept is there signal by noise ratio is called. We call as a noise variable, which is sometimes we call this as a control controllable and uncontrollable. Uncontrollable. All this is uncontrollable. Controllable. This also we call it. There's another calculation for it here, which we call the S by N. S by N. We call it this as a robust parameter design or parameter design. Then we try to find the relationship. Then we try to reduce it. We have to reduce the noise variation. Then finally, another important is we need to have a tolerance design. Tolerance. Tolerance design also. Everything is related to your design. Is more on design, but doesn't mean that this concept can be applied. Once you success, first is what you have to do is once you have to apply the conceptual level at design. Once you what you call it, this is a design where the conceptual level, what the like creativity or innovation happens. Once you complete that stage, then you have to go for parameter stage. Once the concept is established, then you have to find the nominal value for the various dimension and design parameters need to be set. Where we try, sometimes you have to go and see the manufacturing, then only you understand that what will happen. So many design, some ideas will be in conceptual state that we have to convert into technical steps, technical parameter. Then only we can measure it. Then only we can measure it. Once the nominal, once we identify that dimensions and design parameter need to be set, then we try to the parameters which you have chosen, you have to minimize the variation. Very, very important. That is why the noise ratio will come. First idea is there. Then you next stage is you try to design the parameters. Once you design the parameters completely, you design the parameters, then you go for what you call identify the variation in terms of noise variable, controllable variable, and uncontrollable variable. Once you complete the parameter design, then you go to the next stages where you try to find the effects of parameter on performance. Effects of performance in terms of what you call performance. How are you going to find the various parameters on performance? Various parameters on performance actually. How are you going to find them on performance? Finally, there's a level of performance. This is one of the important three stages where we try to emphasize on that. Another is concept is there which is called design of experiments. Actually, orthogonal array or it is a traditional developed theories actually. Traditional where he tried to emphasize orthogonal array, which we sometimes it is called a outer ring. Sometimes it is called as a outer ring. Sometimes we call another important concept is here. But I already told you that it is when you talk about the Taguchi, which emphasize the called, design of experiments. The design of experiments where he came up with a concept called outer arrays, or sometimes it is called as an orthogonal array also. Orthogonal arrays, where he emphasized more or less design of experiment similar to the statistical one, not a different one. But he proposes an experiment called possibly called orthogonal arrays where I have to show with them one example, then only you can understand that. I have to show one example, then only you can understand that how the orthogonal arrays will work. So I will just follow that. More or less similar to what I told you that ANOVA. So more or less similar to concept of analysis of variance. And we talk about a traditional design of analysis of variance, or where we talk about the design of experiments. Which we talk about the design of experiments. Another important concept is there, which is S by N signal ratios. It's a traditional, it is not a new one, but traditional design of experiment which came from the statistical concept. And you would have studied about ANOVA, the same concept taken from that. But he proposed, I don't want to go deep and confuse that, but you remember at least some key terms and key terms related to Taguchi. That's what I'm trying to do over here. Whatever you learn, then I'm trying to relate to that, but I don't want to go deep on it. Don't want to go deep on it. And this is another important concept which Taguchi came up. I told about that. Talked about three designs. How we see how we can apply that. How we can apply that design. Three design stages. Here I talk about three design stages. This is at the conceptual level, then how to start. When it is conceptual level, then you can see determine the suitable working levels of design factors. Identify the design factors. Identify the design factor. Then I talk about the called parameters design or robust design, where we have to identify the various dimension design. First, we will identify the levels. The system design, then we try to find the parameter design. Then we try to find the parameter design. If you look at the what the parameter design is, I told you about that. We are using the orthogonal arrays or outer arrays. It's called as orthogonal array or outer array. Talk about orthogonal array. Orthogonal arrays or outer arrays, where we try to run the experiment, select the proper orthogonal arrays, run the experiment. Then design parameter will have a parameter design will have what you call run the experiment, analyze the called run the experiment, analyze the data, and identify the optimum condition. Try to identify the optimum condition. Then you try to confirmation class. This will come in parameter what you call parameter design. The finally tolerance design is determine the result of the parameter design by tightening the tolerance level. The factors of that, that I can find some example. Some example. You can see this is how I told you about that. We'll have input as a control factors, noise as a what you call noise factor, then quality characteristics, smaller the better or larger the better. These are the three legs, three legs.